right, so just a reminder of what your objectives are. We're performing phase shifts of sine and cosine functions, but actually today we're not just going to do phase shifts, we're also going to be doing period changes. And so compressions with a phase shift or a stretch with a phase shift. So let me just remind you that we're working with the sine function and the cosine function. And today we will be working with problems that could include all four of the variables that would transform your function. Okay, so remember that your A term is your amplitude. It tells you vertically if you're going to stretch the graph or compress the graph. It'll also reflect the graph. Your B term is will affect the period of your function. The period of a sine function or cosine function is 2 pi, and if you divide it by the absolute value of b, that will change the length of the period for one cycle of your cosine or sine function. Your C term, along with your B term, will shift your graph left or right, and then your D term is a vertical shift up or down. Okay, so what I want to talk to you about again, or remind you, yesterday we talked about this a bit. Can you perform the period change and the phase shift at the same time? And it's really useful to do that. So remember what we do. We take one period of the sine function from 0 to 2 pi, just one revolution of the sine or cosine function, and we take the horizontal actions, the bx plus c, set that in the center of a compound inequality and solve for x. And when we solve for x, we'll end up with a new starting point for a rotation and the end point for one cycle of the sine or cosine function. So with this we are going to employ today. Ready? So here are the two problems we're going to look at. Let's start with the sine function. Let's identify all the crucial information in the instructions I forgot to mention. In the instructions, we are finding the amplitude, period, and phase shift, and then we are sketching the graph. And I'll say one other thing. If you still want to draw the parent function and then do one shift or one transformation at a time, continue to do that if that's what works for you. But I am going to offer you some advice so that you can maybe do 2 or 3 things at the same time and draw less graphs, intermediate graphs. All right, so let's take a look at this equation. We have the sine function. Our A term is 1. So that means that our amplitude is the absolute value of 1, which is 1. Okay. Our B term is 2. So that's definitely a horizontal compression, right? We're gonna compress our function by half. So let's find our period. The period is 2 pi for a sine function, and we're going to divide that by the B term, or the absolute value of the B term. And so the period is compressed. Instead of 2 pi for one cycle, we cut it in half to 1 pi. Okay, excuse me. Then we have our C term, which is, what's our C term? Negative pi. All right, and we have to use our C term in conjunction with our B term to find our phase shift. So your phase shift is the opposite of your C term over your B. So that would be pi over 2. So that's a shift right, pi over 2, or a quarter turn on the unit circle. And then your D term is 1. And that's just a shift of the entire graph vertically up 1. So we've analyzed all of the information that we have. We have the amplitude, the period, the phase shift. And after we perform all of that, we'll push all our points up 1. But before we do that, let's see if we can do this horizontal action all in one step by taking one full cycle of the original sine function, the parent function, 0 to 2 pi, one cycle, and let's perform this horizontal action, or both of them. So we'll take 2x minus pi, and we'll solve for x. And we'll see what happens to our start and our stop. So we'll add pi to all three sections. And we get pi less than or equal to 2x less than or equal to 3 pi. Then divide each section by 2. And we get pi over 2, which will be our new starting point for the cycle. And is less than or equal to x is less than or equal to 3 pi over 2. So that's definitely, is that a distance of pi between them? For sure, right? From pi over 2 to 3 pi over 2, that's a pi, that's a period of pi. And it's definitely compressed in and shifted. See what our shift is? Pi over 2. So we're shifting from 0 to pi over 2. So when I go to graph, I'm going to be thoughtful about, since I'm graphing in a positive section here, I don't really need much of the left side of my x-axis. And I'm also shifting everything up 1, and my amplitude was 1. So I think I'll go up to 2. Do you agree? So we really don't need the bottom of the graph all that much. And then, let's see. I guess I'll go out here to 2 pi and pi. And then here's your pi over 2 and your 3 pi over 2. And what I'm going to focus on here is this section of the graph for one cycle of our sine function. We're going to squeeze the points that started at 0 and ended at 2 pi inwards. And so here's something I think would be really useful for you guys to know. When we do a sine function, just watch. You don't have to draw this, but if you would just watch the illustration, I think it'll be very helpful for you. When we draw the sine function, we start at 0 rotation, we're at 0. At pi over 2, we're at 1, right? Pi, we're at 0. At 3 pi over 2, we're at -1. And then back to 2 pi, we start over at 0. Notice the difference in the cycle. In the cycle, from one full revolution, that cycle is cut into 4 equal sections. See? 1, 2, 3, 4. Right? And so we're going to do the same thing inside our new cycle. We're going to divide it evenly into 4 sections. It's already divided in half, so we can just cut each of those parts in half, and we can draw our function. Now, I'm going to go ahead and draw an intermediate step, and then we'll push the point up. Ready? So sine starts at 0, right? And then it's up 1, and then back to 0, and down to -1, and back to 0. Okay, so this would be an intermediate step. So I performed both of my horizontal actions, and it would continue to do that as we go left to right. Are you done? Yes. Okay, just staple it all together and put it right there. All right, now all we have to do is shift all those points up 1. So this point's going to go here. This point's going here, 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 and here. And you have and it wouldn't be a bad thing to extend the cycle beyond so that you can see what the graph is doing beyond one cycle by just continuing the same pattern a little bit to the right of your cycle and a little bit to the left. And there it is. And hopefully that'll save you guys a little bit of time when you have multiple transformations to perform. Do you have questions? You good? Does that make sense? Awesome. All right, let's take a look at the next one then. Okay, so this one has all the variables, all kinds of transformations happening, right? What's your A term? -1. So that's a vertical reflection, right? So I'm going to write over here that that's a vertical reflection, and I have to remember to change my maximums to minimums and my minimums to maximums when I draw my final graph. But what's my amplitude? It's the absolute value of -1, which is 1. right? So that means off the midline, I'm going to go up 1, and off the midline, I'm going to go down 1. All right, what's my B term? So that's a compression of what? A third. All right, so let's take a look at the period that we're going to take 2 pi, which is the period of a cosine function, divided by the absolute value of 3. So the period is 2 pi over 3. Yeah, we're dividing 2 pi by 3. All right, C term is pi. Okay, so that's half a revolution, right? Okay, and so let's find our phase shift. Our phase shift is the opposite of our C term over our B term. So that means we're pushing the graph to the left, pi over 3. And then we also have a D term. Wow. Okay, so our D term is -2, and that means we're going to push the final graph down 2. So we'll reflect the final graph and push the points down 2. Or we'll reflect an intermediate graph, and then we'll push it down 2 and draw the final graph. Okay, so let's do our horizontal actions together. So we're going to take the cosine function for one cycle that starts at 0 and goes to 2 pi. And we're going to perform the horizontal actions 3x plus pi. And we're going to perform both phase shift and period change. So we'll subtract pi from all 3 sections. So that gives us -pi, less than or equal to 3x, less than or equal to pi, divide by 3. And there we have our starting point of our cycle. And let me ask you a question. Is that a distance of 2 pi over 3? Yes? Pi over 3 to the left plus pi over 3 to the right? Yeah, of the y-axis is definitely there. So when I go to draw my graph, first let me think of my y-axis. I'm shifting everything down 2, right? So I'm going to need more of the bottom of my graph than the top. So I think I'll just start at +1, but I'm going to go down to -3 because I've got to shift down my lowest point from -1 to -3. So just thinking about that, and you know what else I want to do? I want to evenly disperse my x and y axis. I mean, my x-axis on each side of my y-axis, and that's because half of my graph is on the left at -pi over 3, and the other half of it is on the right at pi over 3. Truth? And then I think I'll go ahead and put 2 pi over 3 on there just so that I can go a little bit beyond the cycle. So I'm going to graph the cosine function starting here and stretching to here, one full cycle. And remember to do that, I need to take that scale and cut it equally into 4 sections. It's already cut in half, so I'll cut each section in half. And if you're wondering, that's -pi over 6, because pi over 3 cut in half is pi over 6. And that's pi over 6 there. Okay, so if I draw the cosine function starts at 0 or starts at 1 on the y-axis, right? Starts at pi, right? And then hits the 0, hits the trough, hits the 0, comes back up to the peak. And so there's what the function would be if there was no vertical action happening on the graph. But the next thing we need to do is reflect those points, right? So if this was our graph, and I'll go ahead and draw it kind of as an intermediate graph. So it would do that. And I'm going to reflect my maximums to my minimums and my minimums to my maximums to address the reflection. So this graph would look like this. Kind of a cool design, right? And then do what? So that takes care of my reflection. I just have to push all of these points down too. So this point's going to come down here. This point's coming here, 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 and here. And then, of course, I would like you to continue to kind of follow that pattern. Just a bit so that you can see what's happening for more than one cycle of the graph, just so that you can see the pattern of the cosine function. And there it is. I don't think if we work off of this idea here, I really like this idea of doing the phase shift and the period change at the same time, and then just cutting the distance between those two extremes on the ends in 4 equal sections. You're just drawing the same wave over and over again. And then you just worry about your reflections and your shifts vertically. What do you think? You guys got it? Okay, so your assignment is on Canvas, and I would just like to make it an extension of yesterday's assignment. So 9.1b assignment's going to be a 10-pointer. And the assignment, I'll just go ahead and project it real quick, is here. Same exam rules as yesterday. Find the amplitude, the period, and the phase shift, and sketch the graph of the equation. And the problems that we just did in notes were 13 and 15. So you have to choose 4 of these other 6 problems to do. Okay? So you can choose any 4 of the other problems that are projected on the board. And you have 30 minutes in class to get it done. 4 problems, no problem. You can do it.